Can you use a drill battery as an emergency power source for ham radio? This time on Ken Talks Tech. Here's my presentation to the Montrose Amateur Radio Club about an alternative or emergency power source for ham radio.
My journey into ham radio is I think probably similar to a lot of you. I was licensed as a novice back in high school, way back in the dark ages. Not as dark as some of your ages, but back in 1976 I got my novice, 1977 I got my general, and what really attracted me to the hobby was the hands-on experimental aspect of it. And my first HF rig was a Heathkit SB, maybe it was a 104A. But anyway, it was one of the first digital ones of Heathkit. And so I got to solder all the components onto the circuit board and wire the bus, and then the power harness that went from the HF rig to the separate power supply speaker unit. And in my high school science class, actually it was an electronics class, the teacher let us do our own projects, and I had a bag of wire, and I was making a long wire antenna, and he said, "Are you working?" I said, "Yeah, I'm building an antenna." And I came back a couple weeks later and told him I'd made my first contact to a guy in Japan. So I was hooked from that point. But then, like the rest of us, life takes over. I went to college, got married, had kids, and the radios went in the back room and never to be seen again until, but I always kept my license active because I knew I wanted to get back into this hobby. So about 6, 7 years ago, a friend from the 10-ring shooting club in Nucla pulls in with a ham radio plate on his car. So I started talking to him about ham radio, and he said, "Oh, we have a little club here. There's like 3 or 4 of us. We're all on 2 meters, and we can get you going again for like $30. You can get this Bofang handheld to get you on 2 meters." And the last handheld I bought was like a $250 ICOM IC2 something or other. So I said, "Well,
sign me up."
Sign me up. And so I got bit again. So now I have all sorts of handhelds and mobile rigs and HF rigs. But as I got back into the hobby, I started learning about all this mobile stuff, all the new things since the 70s, like field days and parks on the air and summits on the air. And so looking into portable power sources for all these radios. And in doing that, I came up with this little experiment. Next slide.
Okay, do I click?
Yeah, just click.
Nope.
Other click.
Left.
Other button. There you go.
Oh, it works.
So when I was looking into this, there's 4 basic portable power sources that I saw people using. The first, the vehicle battery. You take a mobile rig, put it in your car or truck or RV, and run it straight to the battery, a lead acid battery. Or if you want to, sit on a park bench, you have maybe a deep cycle marine battery and set it on the ground there and wire it up. Those are heavy and expensive. And people are using generators. A lot of RVs have generators. Now the generators like we use at Field Day this year, again, kind of big, kind of expensive. You can generate RF, get a good one. And then there's the portable power stations. So those intrigued me, and so I bought one of the little ones, little Jackery power supply that I used at my first Field Day. And then a month or 2 ago,
I know, and then
Dave
you got
Kessler
given
came
one.
to our barbecue and
Picnic?
he donated five of them and I was the first name drawn, so I now have a 1,000-watt portable power station.
Yeah, thank you, Dave.
Yes. And then LifePo batteries. Well, these portable power stations aren't cheap either, the good ones. And then LifePo batteries, at the time that I was starting to look into this, they were still kind of expensive. So next slide, I asked myself, okay, well, what batteries do I already have on hand that might be able to power my portable ham radio station? And next slide, after scratching my head a little bit, I realized I have several DeWalt drill batteries that are 5 amp hour, 6.5 amp hour. So I thought that would probably be enough. And I started Googling and YouTubing, and of course, It's not an original idea. I don't think there are any original ideas out there anymore. Several people have videos on how to use the DeWalt batteries for powering all sorts of things. They power fish finders on your boat with them. They power your little kids' little Jeeps and Barbie cars and all those things. And ham radio stations. So I said, that's rather than buying extra batteries, I already have these, let's see what it would take and whether it's really a viable option or at least for emergencies. You know, if I'm at home and the power goes out, what power sources can I draw on? So next, when looking into this, there's really only 5 steps involved in using one of these batteries to power a portable ham radio station. First, there's 5 different terminals on these things. Figuring out which is the positive and which is the negative. Very important. Next.
Can be shocking.
Yes. Next, then you need to connect some leads to those positive and negative terminals. Then, we're not seeing the whole slide. Next, because these are usually 18 volts, 20 volts, 40 volts, and now they have 60 volts, you got to step the voltage down to the 13.5 or so that we need for our radios. Once you've done that, you need to connect it to your radio, and the point that is not showing for whatever reason is you may need to drop the power on your radio just so you're not drawing too much current for the battery and the buck converter. We'll get into that in a second. So, real quickly, I'll go through each of these steps. First one, next slide. Determining the plus and minus wasn't as hard as I thought it would be.
It's written on it.
It's written right on it. DeWalt does it, Milwaukee, all of the major brands. It's usually the 2 outer ones, and they show plus and minus there. So step 1, easy peasy, check that one off. Step 2, connect power leads. Well, I first thought about just using like those flat spade connectors you could stick into those terminals. But as I was looking around, they're using these batteries for so many different things. There are tons of manufacturers who make these adapters that just slide on the battery,
Oh, wow.
already pre-wired, with an on-off switch, with an inline fuse holder,
Oh, my
and it comes with the fuse.
Wow.
And it just slides on, and there you go.
No kidding, that's cool.
Wow.
And next slide, they have them for all of the major brands. So if you're a Ryobi guy or what is that one, Makita.
What do they call them?
They are,
Adapters?
I went on Amazon and said DeWalt battery adapter. And there's a bunch of them. And so you do whatever your brand is, battery adapter. But one more click. If you're one of those 3D printer guys, you can go on Thingiverse, and there are all sorts of files on Thingiverse for all the different brands. The only thing is, it just gives you the plastic part, so you would still have to put the spade lugs and the wiring and switch and all that. So for $10, I thought this was a good way to go.
Yeah.
So
You
I
gotta
got
do
that.
Much
something for
better.
yourself.
Was that?
I said, you gotta do something for yourself.
Probably cost 50
Next
to print it.
So step 3 is step the voltage down, because the batteries I'm using are 20 volt batteries. And so I found a buck converter that will take pretty much any voltage from 14 volts up to about 24, 28 volts, and step it down to a constant 13.8 volts. And this particular one handles 30 amps. There are some that will go a little bit lower in the voltage range, but they'll only handle 10 or 12 amps. So I wanted to get the highest amperage that I could find, and so that's the one I got. And this is what the circuit looks like, and I'll have it up here afterwards if you want to take a look at it. We'll get there.
Cost a bit.
I have a slide on all the costs at the end. So, yeah. So this is what it looks like. So we have the adapter on the battery through the switch. I put a meter in line so I could track the voltage drop on the battery and the current that we were drawing into the buck converter and then out. The next slide shows it hooked up to my Zygu G90.
You have one of those.
Dang.
A lot of wires. It's mostly because of trying to get that
Yeah.
amp meter in there. So that's connect the power to the radio, and then step 5 is the, depending on what buck converter you have and what the rating is on your battery, you just want to be careful how much current you're drawing so you don't either fry the battery or your radio. So in my case, it's 30 amps, so I could have gone full power, got a 100 watt, but I wimped out and I didn't test it at 100 watts. Next slide. So the tests that I did, I tested the two radios, my Yaesu FT991A, which will go up to 100 watts, and then the Xiegu G90. Connected to a dummy load, thanks to Bud for loaning me his dummy load for my test. And I just did everything on HF, single sideband, 40 meters, going just directly into the dummy load. And I have current ratings for transmit and current ratings for receive. And so I'm trying to think of a good combination for a typical QSO. I just went 50-50. Transmit for 15 seconds, listen for 15 seconds, transmit 15, then I got bored with that, so I went transmit for 30 seconds, receive for 30 seconds to see how long the battery would last. Next slide. So here's some of the ratings on the Yaesu. Kind of depends on who you believe. The manufacturer is very safe. Worst case scenario, the manufacturer spec says on HF 100 watts, it draws 23 amps. VHF and UHF is 15 amps. ARRL Labs tested it and they said on HF the minimum at 5 watts is 6.8 amps and at 100 watts was only 14 amps. And on VHF it's 9 amps and 7 amps is the max. And then I found a couple of YouTubers who tested it with a similar amp meter or power meter that I used. And theirs ranged from 7.2 amps minimum to 15.3 amps maximum. So next slide shows kind of a rundown of the couple samples of what the YouTubers said the power. So since it was questionable, it's only 15 amps, I should have been able to test it at 100, but I didn't want to risk ruining my radio.
Right.
So I only tested it at 50 watts. But theoretical, how to figure out how long it should last. The time in hours is equal to the capacity in amp hours of the battery divided by the constant current draw, or the average current draw. So at 100 watts, the Yaesu should have lasted, so here's your transmit watts, your receive, or amps, excuse me. Transmit should be 15.3 amps. When you're in receive mode, should be 1.6 amps. So let's average those. 8.45 amps. So 6.5 watt hours was the battery I was using, divided by the 8.45. So it should give you about 3/4 of an hour, 46 minutes, roughly, is what I would expect. Next slide. Same thing with 50 watts. The anticipated would be just under an hour, or 57 minutes. But what I actually got, my transmit, even though the expected current draw at 50 watts was 12 amps, I saw anywhere from 4 to the peak was 10.7 amps. So since it's lower, you would think I would get a longer time, but I guess with it averaged, or somehow the average came out actually higher, even though the transmit was lower. So I ended up only getting 43 minutes.
Instead of 46, I think.
Instead of 57.
Oh, 57.
So it's only 75% of what I expected to get. I'm not sure why it was less.
Because it's always very.
Yeah. So next slide is just for completeness. Here's what it would look like at 20 watts. Should have got an hour, 1.2 hours, or 70, almost 73 minutes is what you would expect at 20 watts on the Yaesu. So, at 50 watts, 43 minutes, still in an emergency. 43 minutes isn't that bad. And if you have several batteries, you can just swap them out real quick and get back on the air. So, still doable. If all else fails, that's the only source you had. So on the next slide, on the Xiegu G90, these are the anticipated current draws. So I just tested at 20 watts, so it should have been around 5 amps. But and what I saw on transmit was right around 2 amps. But the power meter on the Xiegu showed I was transmitting 20 watts. The meter on the antenna tuner with the dummy load said I was putting out 20 watts. but it was only drawing, a peak of 2.37 amps. So since that was lower, I would anticipate that I would get almost 2.5 hours, so 136 minutes. And I actually got longer. I got 155 minutes, so 14% more with the Zygu, which is lower current draw. And on this one,
Sorry.
that's okay, you can delete that. On the Zygu, it never shut off. On the Yaesu, once I hit 53 minutes, or 43 minutes, the next time I keyed up, it went dead, came back up, rebooted the radio, rebooted the meter. So I hit the max of that battery, so shut everything down. On the Zygu, it never got to that point, but I was watching the battery voltage and it got to 15 volts. And I read you don't really want it to get much lower than that. So I stopped at 2 hours and 35 minutes or something like that. So costs. The battery adapter, I ended up buying two. It was 2 for $20, so 10 bucks a piece. The buck converter that I bought was $32. There are some cheaper ones, some more expensive ones. So the total cost, if you already have the batteries, is only $43. Now, next slide, compare that to, okay, I can go out now, the price of the LiFePO batteries have come down. This is actually an 8 amp hour, but if we try to match apples to apples, 6.5 amp hour, I found a 6 amp hour LiFePO for 20 bucks. The 8 amp hour is 30 bucks, and an 18 amp hour that I use for my Go box is $57. But then, of course, you can get a battery charger if you don't already have one. So throw another 25 to 45, depending on how much you want to spend. So maybe double the price, but my conclusion is yes. Is it possible? Yes. Is it viable? If you have a QRP rig or 20-watt Zygu, yeah, it can work in a pinch. Would I do it for going to POTAs or anything like that? I don't think so. I think I'd just stick with the LiFePO.
Yeah.
But if stuff happens and the power grid goes down and my LiFePOs are dead and I can't charge them anymore, and I have a couple drill batteries, in a pinch I can still get on the air.
That's right.
For a little while. Just take the power down, milk it as much as you can, just enough to send for help, right?
Awesome. Mark,
So, any questions?
is that it?
I have one.
Oh,
Yes.
questions?
I'm first. Everybody probably knows this but me. Does the top take more to transmit or receive?
It takes more to transmit.
Takes much more to transmit.
Yeah.
So if you don't transmit that much.
If you just listen, yeah. So I went 1-to-1. My mom told me God gave me 2 ears and 1 mouth, so I should listen twice as much as I speak. So,
That's right.
if you did that, then you would last even longer.
That's right.
But yeah, transmit at 50 watts was around 10 amps, and receive is only like 1.6 amps on the Yaesu. It's only 700 milliamps on the Zygu. Other question?
Great information, thank you very much.
Yeah, that's awesome.